All right, welcome. Today, we're talking about something you use every single second, but probably never even think about. I'm talking about the unsung heroes of our modern world, antennas. They're the invisible bridges that make everything from your Wi-Fi to your GPS just work. I mean, really think about this for a second. How does your favorite song get from a radio station, maybe miles away, right into your car with absolutely no wires? It feels like magic, right? Well, it's not magic. The secret is the antenna. And we're going to pull back the curtain and see exactly how it pulls off this amazing trick. So let's start with this idea of the invisible bridge, because honestly, that's the perfect way to think about it. An antenna is the critical link, the thing that takes a signal from a physical wire and just flings it into the air. And here's the wild part. Once you know what to look for, you'll see them absolutely everywhere. They're hiding in plain sight. That little black stick on your car, that's one. Those tiny invisible lines inside your phone? Yep, those are antennas too. They are literally the gateways to our entire wireless universe. Okay, so they're everywhere. We get it. But what is an antenna, really? Like, if you had to explain it to someone, what would you say? Let's get down to the brass tacks. All right, so the textbook definition can sound a little stuffy. But don't worry about the fancy words. The only word that really matters here is transitional. Think of an antenna as a translator. It takes electricity flowing through a wire and converts it into invisible radio waves. And this is just as important, it does the exact same thing in reverse, catching those waves and turning them back into electricity. And this diagram shows it perfectly. Look, you've got your source, let's say it's a radio station. It creates an electrical signal that zips down a wire. But when it hits the antenna, boom, that energy is launched out into the world as a radio wave. Then, somewhere else, another antenna catches that wave, does the reverse translation, and turns it back into an electrical signal your phone or car radio can understand. It's a two-way street. You know, there's this fantastic analogy for this. An antenna is to a communication system what eyes are to a human. It's perfect, right? Your eyes catch light waves and your brain makes sense of them. An antenna catches radio waves and the electronics make sense of them. And just like a good pair of glasses can help you see better, a well-designed antenna helps a device hear a signal more clearly. It's literally the sense organ for all our gadgets. Okay, so that's the what. Now for the how. How does a simple piece of metal actually make these radio waves? This is where it gets really cool. And believe it or not, the core idea is surprisingly simple. So here's the big secret, the key to the whole thing. It all comes down to one word, acceleration. Get this, if you have a little electric charge just sitting there, nothing, no radiation. Okay, what if it's moving but at a steady speed? Still nothing. But the instant you make that charge accelerate, speed it up, slow it down, change its direction, bam, it starts radiating energy. And that's all an antenna is really doing. It's just a tool for making electrons wiggle back and forth like crazy. The best way to picture this in your head? Imagine you're at a perfectly still pond. If you just stick your finger in the water and hold it there, nothing much happens. But what if you start wiggling it back and forth? You create ripples, right? Waves of energy that travel outward. Well, an antenna is doing the exact same thing, just with electrons instead of water. The transmitter sends a current that pushes and pulls the electrons in the metal, making them wiggle back and forth, millions, even billions of times every single second. And that frantic wiggling creates ripples of electromagnetic energy. And those ripples, well, those are radio waves. So let's see how these waves are actually born. As the charges are forced up and down the antenna, they create this electric field around them. Think of these lines you see stretching out as invisible, energetic rubber bands connected to the antenna. And then, here comes the magic trick. As the current switches direction, those energy fields stretch so far that they snap. They pinch off and detach completely from the antenna. Now they're their own thing, self-sustaining waves traveling out into space at the speed of light. They don't need the antenna anymore. Just like the ripple in the pond, they're free, carrying that information away. So, this one simple idea, wiggling electrons, is the foundation for a whole world of different antennas. It's amazing how many different shapes and sizes we've come up with, each one fine-tuned for a specific job. Let's take a look at a few. First up, we've got the classics, the OGs, wire antennas. These are the simplest form, the foundation of it all. Think of the antenna on your car or the big ones on broadcast towers. They're basically tuned metal rods, kind of like a guitar string that's designed to vibrate or resonate at one specific frequency. Super simple, super effective. Next, things get a little more focused. These are called aperture antennas, and yeah, they look like horns or megaphones for a reason. That's pretty much what they are. Instead of just sending energy out in all directions, they channel it, they focus it into a tight beam. It's like shouting instead of just talking. This is why they're absolutely essential for things like radar and talking to spaceships way out in the solar system.
Okay, now let's zoom way in, right into your pocket. Your smartphone doesn't have a big wire sticking out of it, right? That's because it's packed with these microstrip antennas. They are literally tiny patches of metal printed directly onto the circuit board. It's an incredible feat of engineering to make something so small and flat, so powerful. This is the tech that puts the world in your pocket.
And finally, let's go from the tiny to the truly massive. The giants. Reflector antennas. We all know that iconic dish shape. It's not just for looks. It's a super sensitive ear. Its job is to collect the absolute faintest whispers of radio waves from across the universe and focus all that energy onto one tiny point. These dishes are literally our ears to the cosmos. You know, it's just wild to think about the journey, how we went from seeing a tiny spark jump across a lab to having this global network powered by these incredible devices. It's a really amazing story. It all started with math, with pure theory. In 1873, a guy named James Clerk Maxwell predicted these waves could exist, just based on his equations. Then, about a decade later, Heinrich Hertz actually proved it. He built a simple antenna, made a spark, and detected it across the room. That was it, the very first wireless message. But the person who really ran with it was Marconi. In 1901, he did the unthinkable. He sent a wireless signal all the way across the Atlantic Ocean. In that moment, the world got a whole lot smaller. So, from that one simple spark to the trillions of bits of data flying around us right now, antennas basically turned empty space into a superhighway for information. They really are the invisible bridges connecting us, our devices, and our world. It kind of makes you wonder, doesn't it? What's the next invisible bridge we're going to build? What's the next magic that will connect us in ways we can't even imagine yet? Thanks for tuning in.